Hello, my name is Mary Jewett and I work at the Lakes Environmental Association. Today I'm going to be teaching you some of the properties of water and what makes water unique. I'm going to be doing a few experiments, some of which you will actually be able to do at home. So let's get started. The first thing we need to do is learn a little bit more about the water molecule. Some of you may already know this, but let's review to get ready for the activities. Water molecules are made up of 2 hydrogen atoms and 1 oxygen atom. Hydrogen is positively charged and oxygen is negatively charged, so they stick together. Opposites attract. A single water molecule is so tiny that we cannot even see it, even with a microscope. So you may ask yourself, how can I be looking at a glass of water right now? Do I have magical powers? The answer is no. Sorry, you don't have magical powers. The reason we can see water is because of the first property we are learning about today, cohesion. Cohesion means that water is attracted to water. This means that our tiny water molecules stick together, and they do so in such large numbers that they become visible to the naked eye. The second property of water that we need to know is adhesion. Adhesion means that water molecules stick to other things. Look at all these water molecules sticking to this spider web. Imagine a world where water didn't have adhesion and didn't stick to all these things. Crazy. This shouldn't be a messy one, but things happen, you know? For this you will need a container of water. Got that pretty full. A paper clip and a little piece of tissue paper. I usually have more than one just in case I ruin one. So in this experiment, the goal is to have the paper clip float on the water. So in order to help accomplish this, first we put down a piece of tissue paper and then we put the paper clip on top. If you wait long enough, the tissue paper will sink, leaving the paper clip floating by itself. You might be asking yourself, how is that happening? Why is it staying on top when it should just sink? Why can't it just be normal, like a rock or a button or other office supplies? Before I tell you why, I want you to take a guess. Before I explain, I want to show you one more cool thing that you can try at home. Watch how when I press the paper clip into the water, it doesn't go right in. It seems to be pushing down on some kind of barrier. There it goes. What is going on here? In order to understand what's happening, we need to bring it back to that first property of water, cohesion. The bonds between the molecules on the surface of the water are strong enough that small things can stay on top, like our paperclip. This is called surface tension. If you push down hard enough or drop the paperclip in, the bonds will break. Raise your hand if you thought of the water strider. Water striders stride around on the surface, darting from place to place. This mayfly is resting on the surface. It probably just recently hatched. You can see where its tiny feet are pushing down on the surface tension. Hey, don't hang out for too long. You'll become fish food. If you thought of the basilisk lizard, that is awesome. If you have never heard of this lizard, I suggest you look up a video of one soon. I call this next experiment the penny one. Place a sponge on the towel with a penny on top. You will also need a small container of water and an eyedropper or pipette. You can also use a straw instead of the dropper. Now the goal of this experiment is to see how many drops of water will fit on a penny before it spills off the edge. So make a guess before you start. All right, let's count the drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. Why is there a bubble? What happened to gravity? As you can see, the water is bulging over the side of the penny. Both cohesion and adhesion are at work here. The molecules are sticking to the penny and having a great time. And the bulge is caused by cohesion, creating surface tension similar to the paperclip activity, only sideways. But just like the paperclip, the bonds can only stand so much weight, and if you add too much, check out this jiggly surface tension. For this next experiment, you need your bucket of water still and a piece of paper towel. And if you would like, it's not totally necessary, but a little bit of food coloring. Okay? I like blue because it's watercolored. So what do you think will happen when I just put the little tip of this paper towel into the water? What's going to happen? Let's see what happens when I put just a little bit of the bottom in. Is it doing what you thought it would? I really want to see if the water will reach to the top, but I have a fun idea I want to try instead. So I broke out my markers and decided to have a little fun with this one. I'm like a modern day Monet. The water was able to climb against gravity because of, you guessed it, adhesion and cohesion. The bonds between the water molecules and the surface of the paper towel are strong enough to defy gravity. Think about this the next time you clean up a spill. Oh my, that certainly is... Thank you for joining me today. I hope that you learned more about water and learned about cohesion and adhesion. And now that you have these definitions under your belt, you should be able to see these properties in action everywhere you turn. Anytime you look at water, I hope that you're thinking about what makes water unique and why it works the way it does. And I have one more challenge for you. I want you to choose either cohesion or adhesion. And I want you to imagine what the world would be like if water did not have cohesion or adhesion. So think about everywhere that you find water and imagine how everything would be different if it didn't have cohesion or adhesion. It didn't stick together or it didn't stick to other things. So that is my last challenge to you.